Okay, so we're going to start our discussion for this unit on a short review of the smallest unit of matter and what is composing all of these different um, compounds and substances that we need to be well. So let's watch this first. So what is the smallest basic unit of matter? Well, hopefully you remember that that is an atom. And sorry, the atom has a very specific structure. And this image here shows you the structure of the atom. That in the nucleus, you're going to have protons and neutrons. And then swirling around the outside in what's called the electron cloud, you're going to have electrons. Now, all living things are made up of atoms, and these atoms are specific to specific elements that are found within the periodic table. So if we look at the structure of an atom and like what each of those components are, electrons are negatively charged, and like we said, they're outside the nucleus in an electron cloud, and the electron cloud is the region around the nucleus. Protons are positively charged, and they are located in the nucleus. And these are the defining elements of an atom. And then finally, we have neutrons, which are neutral charge, and those are located in the nucleus as well. And these actually provide the most weight to the atom itself. So now, knowing all of that, for elements such as carbon, we're going to use that as an example. There's defining elements of an atom of why they're arranged on the periodic table the way that they are. So for carbon, its atomic number is 6. So an atomic number of 6 tells you the number of protons, which is the defining element of or defining feature of an atom. It also tells you the number of electrons. So when this element is in a neutral state, doesn't have a charge, it's always going to have an equal number of protons and electrons. Then you always have the symbol and the name. And then you have something called the atomic mass. So atomic mass is the mass of the carbon when you add the number of protons and neutrons together. So this would be considered carbon 12 because it has a mass of 12. There's different types of carbons, which would be called isotopes, and there's different types of other atoms as well that are called isotopes of that element, and those would have different atomic masses, and that would be then a different number of neutrons in each of those. So like I said, different number of neutrons is a different isotope. So for instance, there's carbon 14, which would mean that instead of having 6 neutrons, it would have 8 neutrons instead. So then depending on the element you're talking about, obviously all of these change. So if we look at the periodic table, for instance, and we look at, say, helium, it has a 2, so its atomic number is 2. It has 2 protons, 2 neutrons, 2 electrons, and its atomic mass is 4. And so they're arranged in order based on the atomic number. And there's different types of elements on here, and they're arranged by the type of element, which you'll get more into that when you get to chemistry. So what are atoms? What atoms make you up as a person? And what ones are we going to be seeing a lot of in this unit when we talk about different compounds? So hydrogen, carbon, oxygen, nitrogen, calcium, phosphorus. These are probably the most important elements that are found within you. We talked about in the last unit that carbon is found in all organic beings, and these obviously are all the basis of what makes you up as a human being and most organic beings. So some of these elements are very reactive, and they can react on their own, and so that's part of what we're going to be looking at is how do these different elements react together to create new compounds, and then how do those compounds, how are they used within our body then later on.
Okay, we're rolling.
We're rolling?
Yeah.
Right. 15 feet. Whatever, man.
Back up a little bit, guys. 5. And then
This is pretty lame.
I
Burn the algae.
So this is sodium in this video, and it's raw sodium, like this big raw chunk of it. And you probably have seen videos of this before, but yeah, it's explosive if you put it in water, and so that shows you that some of these elements are very reactive even on their own. So then elements can combine to form other compounds with other elements as well. And here's an example of that.
Hydrogen peroxide, but it's not what you get in the store. Hydrogen peroxide is actually H2O2.
Okay.
So H2O is water. They put an extra oxygen on it, you got hydrogen peroxide.
You get a weaker version than the store?
Because
I used to intentionally cut myself so I could pour
the bubbling?
so I could sizzle up my...
Yeah, the stuff that we use will actually give you a chemical burn.
Okay, so don't use it.
Don't.
Okay, great. All right. So, all right. So what do we do?
We're going to get started. We're going to start with a little bit of actually dish soap. So if you want to put some dish soap in your flask.
How much? Just a squirt?
Yeah, a little more. That's good.
Okay.
So dish soap will keep the bubbles because we're going to remove the oxygen. They'll hold the oxygen.
Okay.
So I'll put a little bit in here.
Mm-hmm.
All right. Next, coloring. We have green and red. Do you have a preference?
I'll take red.
All right.
It's very Christmassy. How much of this?
And just keep going. Keep adding well.
Okay.
That's good. A little more.
This is going to be delicious.
All right.
Is this how you did your jacket?
That's good there. Okay. All right, so I'm going to add the hydrogen peroxide because you don't want to do that.
Okay. Oh, it's dangerous, right? Okay.
And actually, let's get all geared up here.
Okay, good. Put these on my eyes.
There we go. All right, so in goes that.
Mm-hmm. And now, what's happening here? What process are we about to see?
So here's what we're going to see.
Mm-hmm.
We're going to, in order to remove the oxygen, we're going to use a catalyst.
Okay.
The catalyst will speed up the reaction. So that's what's in here. It's a sodium solution. We're going to pour that in, and that's going to remove the oxygen. The soap is going to hold it, and
we're going to smother to death, all of us.
It'll be okay, but it will create a lot of bubbles really fast.
Okay, great.
And usually this is done in graduated cylinders, but we're going to make it a little more intense with these ridiculously large flasks.
Okay, good.
All right. So this is what you're going to use. We're going to pour that in there. The oxygen will be released, and we'll watch the reaction. We're going to need to step back after we pour it.
Okay.
All right. Here we go.
Step back.
Ready? 3, 2, 1, pour. There we go.
So obviously, as seen in that video, this is a way of combining something or actually breaking something apart. And then that is creating compounds, breaking compounds apart. And so I just think this is a fun demonstration to show, because you're taking something like hydrogen peroxide, you're adding a catalyst, which speeds up the reaction to break it apart into water and oxygen. And then by adding the soap, it is showing the process of like what's happening on a larger scale. So it makes it look really cool. The other thing you can do, actually, because there's oxygen being produced, is you can light a match, blow it out, stick it in the bubbles, and then it'll relight the match because there's oxygen present.
And we're going to use...
Okay. Now, when we make compounds, we have different types of bonds that need to be made when we're making these different compounds. And we're going to be talking a lot about how different molecules are made, and they're called macromolecules because they're really big. So the first type is ionic bonds. So ionic bonds are when you have a specific type of like metal bonding with a non-metal. And this is going to form an ion that's either positive or negative. And these electrons are donated from one atom to another. And it's usually some kind of white crystal solid. So in the case of table salt, you have a sodium donating an electron to a chlorine, and it creates a bond, and then it creates sodium chloride, which is also known as table salt. If you have a battery and you rub it against each other to create like friction and then hold it above salt, the salt will stick to the bottom of a battery, or it'll even stick to the bottom of a magnet as well. Then we have covalent bonds. Covalent bonds is when electrons are shared as pairs between different elements, and this forms a really strong bond, and they can share up to 1, 2, or 3 pairs of electrons, so it's single, double, or triple bond. And a lot of times carbon, oxygen, nitrogen, and hydrogen are ones that are very common to do this. The example in the image is a water molecule. So water is H2O, and so there's 2 hydrogens and 1 oxygen. And then finally we have peptide bonds, and this is also a form of a covalent bond, but it's a type of bond that holds amino acids together, and amino acids are linked together to create proteins. And this typically happens between a carbon and a nitrogen. And then finally we have hydrogen bonds, and hydrogen bonds are when there's an attraction between hydrogen and another element. And hydrogen bonds are very weak, but they're very important. They're very important to create all of the very unique special properties in water, and they are also important to help with stability of the DNA double helix by holding the bases together. And then I have a couple more videos to kind of show. It looks like this left one's not going to play, but I'll show you this right one. So this is actually a type of bond that's being created of why we can fry an egg. So think about like what kind of food group is an egg? Well, it's a protein. And so if you think back to those bond types that we just talked about, it's actually forming peptide bonds. Peptide bonds are forming between the different amino acids, and that's what's solidifying the egg. So it's actually covalent bonds or peptide bonds, either one, that are forming within the egg. So it's pretty cool. So that is atoms, elements, and types of bonds, and we'll be doing some different types of activities with these as we move forward.